So this next part here, we're looking at rates of change, okay, or slope. So before we were just looking at the changes in the y values, but we want to look at slope, which is change in y over change in x. So this last part here was we were just looking at the changes in just the y values. But the changes in y values and the rates of change actually are very closely related. So we're going to start looking at slope though. And if I take a look at this slope graph, this is a y graph function. Okay, I want to graph the slope. I want to know what the slope looks like. So if I take a look at from this A section here, this piece has this slope. It looks like it's positive, and it looks like it's kind of positive. I don't know exactly what it is, but I'm going to put it up here. Okay, so there's my, and it's constant. Okay, so there's my slope for A. The slope for B, well, B is flat, so anything that's flat has slope of 0. So from here to here, I have slopes of 0. Okay, and I'm going to actually I can't really say what slope is at those endpoints either, so I'm just going to make those open circles, because really at that point there, just that little vertice, we can't really say that there's any definitive slope, because we don't know if its slope is the purple slope, the red slope, or some other slope in between. So we're just going to say for now that those slopes are undefined. Okay, and so we'll go moving on to slope of C here. It looks like it's negative, and it actually looks pretty symmetrical to A, so I'm just going to draw it down here about the same y value but negative. Okay, so there's my slope of C, and it's constant, so it's going to have a constant y value. And the last part here, we'll look at, let's do this in blue here, and that looks like it's positive, but it's definitely not quite as high as slope of A, so I'm just going to draw it like that. Okay, so those are my slope graphs of that function. Now, we have these jumps, or what we call discontinuities. And the reason why we have these jumps is because we have this abrupt change of slope, right? It goes from slope and then all of a sudden changes abruptly. Okay, so we want those give us these discontinuities in our slope graph, right? Those discontinuities there. So if we want to avoid those discontinuities, what we can do is we can smooth out the slope here. So it's a gradual transition. So we need to make the graph smooth. So we need to make the graph smooth. And that gives us a continuous transition of slope. Okay, the smoothness is an important feature of this. If we just make it kinked, then we have an abrupt change, so we get a jump in our slope graph, which causes discontinuity. However, if we just gradually change that and make it smooth, then we can avoid these discontinuities. So we want to find slope, and we want to find slope on smooth graphs. Okay, it's these nice smooth curved graphs. We want to find slopes on them. The problem is, if we want to find instantaneous slope, okay, so if we need to draw a tangent line, so see that line there? That line is tangent, so it just touches at one point. It's definitely at that point. It's the slope of that curve at that point. Now we run into a bit of a dilemma if we do that though, okay, because we need that just the touching there. The touching line has slope. But the problem with the touching line is that when we find slope, we use this formula. Okay, y2 minus y1 over x2 minus x1. Okay, to find that slope, y1 and y2 are the same, so we get a change. The change in y is 0. And the change in x is also going to be 0. And so that slope, 0 over 0, in this case, looks like it's about, we don't know what it is, but it's actually 2. So how do we get from 0 over 0 to equal 2? Well, in fact, 0 over 0 could equal anything. Okay, so this is a big problem. In this case, this specific case, it's equal to 2. But 0 over 0 could be equal to 0, could be equal to -2, it could be equal to 15, it could be equal to infinity. We don't know. It all depends on how we get there. So this is a big problem here. Our slope here of the tangent line, this is our slope of a tangent line. Okay, so this becomes our dilemma. Okay, we clearly can see it physically has slope, but how do we calculate it with 0 over 0? So this is something that we're going to have to figure out. We'll have to wait till later to do that though. Okay, so what we can do though is we can kind of estimate what this looks like. And we're going to do this using what we figured out up here, that our changes of a quadratic graph are linear. Okay, so our first change, if we go back up here, the changes in y of a quadratic graph are linear. Well, that means that when we calculate the slope of a parabola, we're probably looking at the changes are linear. Or we can then say the slopes should be a linear function. So if we take a look at this, we can just see, we can graph this and we can just take some references here. I'm just going to say that this point here, 0, I can clearly see that's a horizontal tangent line. So that has a slope value of 0. Okay. I can see that on this section, it's smooth and continuous. So the slope is gradually changing, but it's changing from 0, gradually getting more and more. And I'm going to say that, and I don't know how steep that's going, but I'm going to say that that graph is going to go in that direction. Okay, it's going to increase linearly. And if we take a look at this section here, well, this section of the graph is negative slope, so the slope values are down here, and it is continuous and it's smooth. We don't really know how it changes, but we know the y values change linearly, so we can then make the guess that this slope here is changing in a straight line pattern as well. So I'm just going to draw it like that. So this is this graph, y equals x squared, I think it is. This parabola is going to give us a slope graph that looks like this. So this where this graph represents the y values represent slope values. So we're using this fact that the changes in the y's are linear, so we should see a linear change in the slope. Now, if we're going to take a bit more of a leap of faith here, because here we have a cubic. And again, with the cubic function, we can clearly see where we have 0 slopes. Okay, right about 2 point something. Okay, sorry, it's going to be about 1 point something. So I'm going to have 0 right about here and right about there. We know those are clearly tangents that are horizontal. And we have positive slope here, negative slope in between those zeros. So that means our slopes are going to be up here. Okay, so I'm just going to maybe draw that in. Let's do this in green. So I have this is positive slope and it's smooth. Positive slope here and it's smooth. So we should have positive slope up here on this side and positive slope on this side. In the middle, that slope is negative. So in between, we should have negative in here. Okay, so let's do this a little bit more accurately. Okay, let's take a look at the green here. And we're going to say that we are having really big, tall slope, and it's gradually, continuously or smoothly going to 0. So it's going to be a really big slope, and it's going to go to 0. We can say it's going to go straight down to 0, but wait a minute. I remember that the cubic changes are quadratic. So I'm going to give this kind of a quadratic shape of a parabola there. In between, it's negative. Okay, I'm going to be negative here, it's going to go from 0, really negative, and then it's going to start becoming less negative here. So it's going to go down and back up. And what we're seeing is really a quadratic change. So 0, negative, back to 0. And again, if we look at this part here, yeah, it starts at 0 and it's going up, 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 really big, and it's going to change in a quadratic way. So we're going to end up with this quadratic pattern. So the changes in a cubic are quadratic. So what we can say is the slope values follow a quadratic pattern. So this is a very useful way to look at things if we look at the changes. So it's really, we're kind of guessing at these things still. We really have no clear way to get them yet. But in general, we can make these generalizations. These generalizations then do hold true. Now, it is important to figure out, well, what are some key parts to look for when we're drawing these graphs? Well, clearly these zeros were really helpful because they really help us lock some positions. That's the only things we actually know. Okay, so the key features are where the slope is 0. Okay, so that's definitely a #1 key feature. The other things we should look for are where the slopes are positive and where the slopes are negative. These really help us clearly identify key features of these graphs.